Hello everyone, this is episode 2 in a series on problems you need to be able to avoid when you read statistics in the news if, like me, you don't want to be led astray by bad reasoning, or worse, by dishonest experts and snake oil salesmen. This episode is on the dangers of data dredging, which is a very common problem nowadays, because the evil of data dredging is amplified by nice modern computers with spreadsheet software and similar things. Spreadsheets allow anyone who wants to test lots of hypotheses or compare lots of experimental results in a way that was not possible in the good old days. The problem is that now people are then tempted to, and often do, throw away lots of non-significant results until they find one which appears to be statistically significant, according to some special standard textbook test which they think is correct. And then they just report that one statistically significant result and claim that it is probably true. Data dredging, this problem, is also called the file drawer problem, which is a name that conjures up a picture of all the null results, the non-significant results, being dumped into a filing cabinet, and only the rare so-called good result kept on the desk and published. Now, I said data dredging was not so easy a trap to fall into during what I seem to be calling the respectable good old days, say the 1930s, when, for example, statistical analysis of crop breeding experiments genuinely helped to produce the green revolution in agriculture that has so benefited the modern world. That's partly because in the good old days people could not easily do the modern useful but also risky technique of large-scale computational data mining, which is what can cause the problem. But that's not the only reason. In fact, back in the 30s there were many statisticians who, like Ronald Fisher, understood perfectly well that data mining does carry a risk of bad interpretations. And they not only warned people about data dredging, they invented some analyses that would prevent the problem, like ANOVA, which I'll mention briefly later. And nonetheless, nowadays, conclusions from data dredging are commonly found, bulking out the news on subjects like health and lifestyle research or economics. But a simpler example for us to understand the essence of data dredging is this charming story from Germany. In this story, an animal named Paul the psychic octopus is said to be able to predict World Cup football match results. Right. Paul the octopus's predictions of the winner of a football match, these were made, according to the newspaper article, by giving him plastic boxes containing an identical bit of food, and each box had the flag of one of the competing teams. The box which he opened first was his prediction for the match winner, and he had a remarkably successful run. Indeed, he called all 6 of Germany's matches in the 2010 World Cup correctly, which was so unlikely that one could compute it as being statistically significant at the 5% level, compared with a null hypothesis that he was choosing boxes at random. Now, I guess we can agree that journalists enjoy writing about psychic animals. This is because the amount and simplicity of the facts, I think, are at the right level for a person with a degree in journalism to enjoy. Anyway, also these stories are entertaining for us to read as well, so they're not that bad a thing for the journalist to write about. But anyway, I'm sure we can actually agree that what is happening here is that many zoos around the world have each chosen one of their animals and invented some way to get him or her to predict the World Cup football results. Most of these animals turned out to be pretty lousy pundits, but we don't hear about them. Nonetheless, soon we do get to read a press release about the one animal among many that has had an amazing winning streak. Actually, it's no surprise that one of the animals guessed all the results correctly, any more than it's a surprise that a few people win the lottery most weeks. But Paul the octopus is then presented to us as a psychic animal rather than as what he is, which is one lucky animal among the many we didn't hear about. This misinterpretation is the essence of data dredging. I'm sure you can see how this problem brings about many intriguing but rubbish news headlines, or indeed research papers. However, two different versions of data dredging are worth knowing about. Case number one is the classic version I've described with the psychic octopus. In case number one, someone throws away these no-effect results from different animals. But at least when they report on Paul the psychic octopus, he is at least a unique animal, different from the others. So you can just about imagine that he might have some unique capabilities. This case number one is a problem when we're testing whether new drugs are able to treat illnesses, because it's often necessary to screen thousands or more candidates by trial and error, so some of them might appear to have a benefit by chance. But this problem in drug development is actually fairly solvable by requiring the apparently successful candidates at one stage to pass further stages of testing, until the chance of one succeeding in all of the stages by accident becomes negligible. Case number two of data dredging is much worse. It involves throwing away studies which show no effect on the same candidate until a study is finally obtained which does show an apparently significant effect. And then the dishonest investigator uses that to claim that there is an effect. This would be like buying several lottery tickets and, if one wins a small prize, then claiming that you have a 100% success rate at winning at least a small prize. In other words, that would be simply an incorrect claim. I suspect, without having bothered to look this up, that some claims about the dangers of vaccination arise from this case number two. In other words, ignoring studies that actually do indicate no harm until one, by chance, does indicate harm. That's my suspicion, anyway. Another reason data dredging is a problem is that scientific studies do sometimes involve using judgment to throw away early measurements which you think, for example, probably weren't done very well, and then taking the ones that you think were done very well at the end of the work. And in some cases there's no way to avoid this problem because your work might really get better towards the end of a study. Instead, what you do need to do is at least bear in mind in your own work, and if you read other people's stuff, is that even the best quality research might sometimes not be done right. A judgment might have been used wrongly. Okay, how do we avoid being misled by this process of data dredging? Well, if you're actually doing research for yourself, it's quite straightforward. Simply, before you throw away data, you do a correctly chosen initial test, such as Ronald Fisher's ANOVA, or Analysis of Variance test. This initial test asks whether the complete data set, such as one winning streak among 100 zoo animals whose World Cup predictions were collected, is surprising. If it is surprising, then you can throw away the other data and have a closer look at the results of the most successful animal, now that you have successfully data mined it from the mass of results and concluded that it didn't come about, it most likely didn't come about by chance. The same thing applies to drug development and plant breeding, except often there you might have multiple stages of testing as well. Alternatively, instead of using the ANOVA technique from the world of sampling theory statistics, a correctly written Bayesian analysis would, pretty much by definition, by the construction of Bayesian analysis, a Bayesian analysis would also lead you to the correct logical conclusion. So that's data dredging, which you have to watch out for. If you're not doing the research for yourself, but reading a statistics headline, you won't necessarily be told whether they have wisely applied a method like ANOVA before discarding any adverse data. In that case, you have to ask yourself whether the experts in the story sound like they are honest and properly skilled in statistics. And I wouldn't count on it. Have a great day, and return for more statistics notes in the future.